we're looking for a 4-digit integer with this property regarding the sum of the divisors. And so what I'm showing you here is just the natural try. 1,000 is the smallest 4-digit number, right? So I gave it a whirl. Now, again, what we're trying to do here is find a 4-digit positive integer such that the sum of the divisors of that integer minus 1 is greater than the sum of the divisors of the integer. That's what this sigma means. It's the sum of the divisors. Now, so I tried 1,000 for what I just said. And if you take a look here, 1,000 minus 1 is 999. 9 times 111 is a factorization, but it turns out 111 is equal to 3 times 37. Now, the reason why I went to all this trouble is because there's a relationship between the number of divisors and the exponents, right? You increment each of these exponents. 3 incremented is 4, 1 incremented is 2. 4 times 2 is 8, and so you have 8 divisors. So 999 has 8 divisors. We don't need to necessarily know what they are here to draw a conclusion. Now, in a similar fashion, 10,000, 2 times 5 is 10, so we can cube it, and we get this. If we increment each of these exponents, we get 4 each time, so 4 times 4 is 16. So we have 16 divisors here and 8 divisors here. Since 999 and 1,000 are so close, that means the sum of the divisors of 1,000 is definitely going to be greater. Okay, so that's why I wrote not greater than right here. Now, there's a way to find it exactly, but I think the argument's strong enough. If you have this many divisors over here for a number that's very close to 999, then there's no doubt that the sigma of 1,000 will be larger. Now, so we're looking for, so that doesn't work, so we're looking for another one here. Now, let's come down and take a look here. And again, the sigma function is the sum of the divisors of an input number. Now, let's take a look right here of this little result here. I'm going to give you just a brief proof of it because it's going to help us solve this problem. Now, notice that if n is prime, n only has 2 divisors, namely n and 1. So sigma of n is just going to be n plus 1. Okay? Again, just think of a number like, say, sigma of 11. Okay, sigma of 11, this is almost, you think of as a definition of a prime number. 11 wouldn't be prime if 1 and 11 weren't its only divisors, but that sum is going to be 12, right? So you see, I'm just generalizing that right here. We're given that n is an odd prime. And so we get this result n plus 1 right here. Okay, but notice that if n is an odd prime, n minus 1 is even, right? Let me write it directly above here. If you subtract 1 from any odd number, you get an even number, right? So n minus 1 is even. Okay. Now, it's very easy to write down the sum of the divisor. I'll write around directly above so you can see that it's greater for the general case. You have n minus 1 clearly is one of the divisors. That's always the case. All right. Now, notice that since this is even, you have to add a 2 in there because it's going to be divisible by 2 also. Another 2, another power of 2. I mean, just another 2, okay? And it's also plus 1 here. Right, folks, so you get that? N minus 1 is guaranteed to be a divisor since any number is a divisor of itself, right? Okay, but it is an even number, so it also has to be divisible by 2, all right? As long as it's an odd prime. Now, and then also 1 is always a divisor, but what is this equal to, folks? This is just equal to, this whole thing is n plus 2. See, so we have this n plus 2 is always greater than n plus 1 in this scenario. Okay? So this is a guarantee. Anytime you have an odd prime, you have this kind of counterintuitive looking result where a smaller input is actually evaluates to on the functional level is larger than the larger input. Okay? So now, so the key here is just to search around for 4-digit primes that are relatively small. Now, I'm going to go ahead and write down 1001 is not prime, and that takes a little bit of work. 1002 is definitely not prime. 1003 is not prime. 1004 is not prime because it's even. 1005 is not prime because it's divisible by 5. 1006 is not prime, and it takes a little bit of work to show that. Okay, there's some digits test, or no, 1006 is an even number, right? And also in a similar fashion, 1007 is a composite number, it's not prime. 1008 is an even number. But we can show you that, or I will just tell you, 1009 is prime. Now, let me write that down. 1009 is definitely prime. And it's nothing special about getting the smallest one. But I don't think I think this is the smallest 4-digit prime. Okay, it's not important as far as the nature of this problem. Now, notice that 1009, 31 and 32 trap its square root. Let me write it like this. There's a very classical result in number theory that says you can check to see if something is prime by just checking all the prime factors less than its square root. So that's why I'm writing this down. So the square root of 1009 is trapped between 31 and 32. Remember, 32 is 1024. 32 squared is 1024 because it's 2 to the 5th squared, 2 to the 10th, which is 1024. Okay, so all you have to do here, and again, it's a little bit of work. I'm going to leave out that work, but 2 is definitely not a divisor of 1009, right? Because it's even. And also, let's see, 3. You can check on the sum of the digits. You have a sum of the digits that's not divisible by 3. 5 is clearly not. Okay, let me try to increase this list here. So we have 3, 5. It's clear that 2, 3, and 5 by easy divisibility tests aren't divisors of 1009. It's not quite as, you can do 7. I won't go through that test. There's a divisibility test where you can multiply by the last digit, divide it, subtract it and all that, and it won't be divisible by 7. But just, you have to go through all of these. 11, there's a famous alternating sign test for that. It doesn't work, okay? Now the rest of them aren't so obvious, but I'm just going to write down that these are the ones you would have to check. 13, 17, 19, 23, you'd have to check them all the way up to 31. Okay. So y'all, this is time consuming right here. This is, I'm not, and again, I'm not going through that work. It's just too boring to, but so 31 is the next one. Okay. But anyway, suffice it to say 1009 is prime. And so we've just shown that that means that sigma at 1008 from our earlier work. Y'all don't know what's wrong with this goddamn mouse. Okay. Okay. I think this is just overloaded. But anyway, this is sigma of 1009. Okay. 1000. Some kind of lag on this piece of shit. Okay. I got to get a new platform. Okay. But y'all, so we have done it. We came up with an example of a 4-digit where sigma of 1008 is greater than sigma of 1009. Now notice we didn't go through an exhaustive check here, just this enough. There's going to be some other divisors of this, right? There'll be some other divisors, definitely, but just this enough, just knowing that n-1 is even means that 2's got to be a divisor and 1's got to be a divisor, and that would exceed the sum of the divisors of n, because n is known to be prime. See, so it's kind of a crude thing, but it works without having to go to the trouble to sum up all the divisors of 1008 in this case, because this general case means that this is true. Okay, so this is an example of a 4-digit number with that property. All right, y'all. Y'all let me know if you know of a platform I can use it. My mouse starts going dead in this app. I'm using Microsoft Word. It's been working well so far, but I don't know if it's because the document is so large or what, if there's some kind of overhead in the system. But let me know if you know of another platform I can use to present these problems. All right. Thanks for viewing.